This is an AS mechanics question on SUVAT. A man throws a tennis ball into the air so that at the instant when the ball leaves his hand, the ball is 2 meters above the ground and is moving vertically upward with speed 9 meters per second. The motion of the ball is modeled as that of a particle moving freely under gravity, and the acceleration due to gravity is modeled as being of constant magnitude 10 meters per second squared. The ball hits the ground t seconds after leaving the man's hand. Using the model, find the value of t. So let's start by drawing a diagram. So this squiggly line here is going to be the ground. The ball is thrown up from a point which is 2 meters above the ground. Then it's going to reach its high point and then it's going to drop and hit the ground. So the distance between the point where it's first projected and the ground, as we're told in the question, is 2 meters. Gravity always points towards the ground, and in this case the value of g is 10. So watch out for that, because normally you would take g as 9.8, but here we've been asked to use a value of g of 10. The initial velocity upward, well, that is 9 meters per second, so we'll just do an arrow here and show 9 meters per second. And we want to find the time it takes for it to go up, reach its highest point, and then drop down and reach the ground. Now, I tend to like using the original direction of a particle as positive, so I'm taking upwards as my positive direction. So now we're going to write out SUVAT and write down what we know. So first of all, S, we want to find the time it takes to hit the ground. So that means the time it takes to displace in a negative direction 2 meters, because upwards is positive. So a negative displacement will be below or going downwards. So S is going to be -2. U, well, that's just going to be 9. V, we don't know and we don't care about, so I'll just leave that blank. A, well, A is going down. Upwards is positive, so that's going to be -10. And T, well, that's big T. That's the thing that I need to find. So I now need to decide which SUVAT equation I'm going to use, and it's going to be S equals UT plus half AT squared, because those are the letters that have been used, S, U, A and T. So now we just substitute these values into the equation. So that will give us -2 is equal to 9 capital T plus half, A is -10, and then capital T squared. Let's simplify this. So you'll get -2 is equal to 9t, and then half of -10 is going to be -5, so minus 5t squared. This looks like a quadratic, so let's rearrange it to look like a quadratic. So 5t squared, if we move that across, minus 9t minus 2 is equal to 0. Let's factorize this quadratic. Now, since we've got a coefficient of 5 in front of the t squared, when I factorize it, then one of the brackets has to be 5t at the beginning, so the other one's going to be t. And now it's just a matter of working out what numbers I need to put here. Now, the numbers need to be 1 and 2. So let's have a think about it. If I put a 2 here, I can get 10t or minus 10t. So I really want a minus 10t. So minus 2. So that afterwards I can add 1t to it. And I can see from there that this is the correct factorized form. So from this I can work out what the values of t are. So from the first bracket, 5t plus 1 is equal to 0, which means that 5t is equal to -1. That will give me t is equal to -1/5. So I'll reject that solution because t can't be negative. And then for the other bracket, that's t minus 2 is equal to 0. That gives t is equal to 2. That's fine. I'm happy with that solution. So my final answer is going to be that t is equal to 2. So it takes 2 seconds. So I can put the S for seconds as well. for this tennis ball to go up in the air and then back down and hit the ground. And this seems like a sensible answer. So when you do questions like this, look at your answer and think to yourself, does that seem like a sensible solution? That will help us reject any solutions that are definitely way off, or it may indicate to us that maybe something's gone wrong in our working.